Hello everyone, welcome to organolysis. So this is our reaction part 3. So in this video we are going to discuss about typical different types of lithium based reduction reaction. Okay, so actually this is the first we are taking, that is lithium aluminium hydride. Okay, so this is very known and very popular reagent, we all know that. So how this reactions proceed and how this type of reagent works in different types of compound, different types of functional groups, and I will discuss all those topics related to this only on this lithium based compounds. Okay, so lithium based compounds of which is performed by the reduction reactions. Okay, so let's start. So see, first we are taking the compound which is very much known and very much popular, that is lithium aluminium hydride. So this lithium aluminium hydride, what it does, it can reduce this ketone to corresponding to this alcohol. Okay, so this is basic reactions. Okay, so now let's have a look at the mechanism and how these reactions proceed. Now see, the aluminium, if we take this lithium as a salt, that is lithium is in plus state and this is your minus, and from which the hydride is donated to this ketone, okay, over this carbon. Now see, this hydride is first donated to this carbon, and this is a type of nucleophilic attack over this carbonyl, and this bonds goes back to the oxygen atom over here. So this oxygen atom is negatively charged, and this negative charge is coordinated with this aluminium hydride. So this is negative charge over this aluminium center, and after that if you put that, okay, now see, this has this is not only ketone, so various of ketones are present in these reactions here. So this is correspondingly attached to this aluminium hydride, and combining this and this step 1, step 2 and step 3, and you can, after the hydrolysis, you can get this corresponding alcohol. Okay, so this is how the reactions proceed, and this is a very general mechanism of lithium aluminium hydride. Now see how the reactions how the different type of functional groups react with this type of reagent. Now see, this is I'm written over here a chart, that is common functional groups reduced by this lithium aluminium hydride. Okay, so you all know this type of this is our functional groups, and this is our reduction product after the reduction by using this lithium aluminium hydride. Okay, so this is the overall product, and the functional groups are there. So okay, you can take a screenshot of this compound. I'm still here. Okay, so I think you can screenshot of this page. Okay, so let's see. Now see, this is your aldehyde, and this aldehyde are reduced to corresponding alcohol. This is primary alcohol, and the ketone also reduced to this alcohol, and this is your R prime. That is, R prime is nothing but just R prime is just any kind of alkyl group, that is a kind of ester. So this esters is reduced and corresponding to its alcohol, and its form and this form the other part, that is your alcohol part. Okay, so this is your primary alcohol. Now in case of acid, that is carboxylic acid, this is also reduced to this primary alcohol, that is CH2OH, and this is a kind of amide bond. This amide bond also reduced to this amine CH2NHR, and this is your cyanide or nitrile. This nitrile is also reduced by using lithium aluminium hydride. You can get this CH2NH2. The nitro also reduced to corresponding amine NH2, and this. Now here is an important concept. It is that this type of halides or any kind of if there is any kind of reducing agent written like that, if there is any kind of leaving group. Okay, so this type of leaving group, and this bond is also cleaved by this type of reagent, lithium aluminium hydride, and it can also do this type of things, that is CH2Br and CH2OSO2R, that is also a leaving group. These bonds also cleaved, these two bonds also cleaved by this lithium aluminium hydride reagents. Okay, so that is how this so after the hydrolysis, after this reduction, that is bonds is cleaved, and it takes a proton over here. Okay, so this is your CH3, and here is also your CH3. Okay, so this is your product. So this is very much important, these two. Okay, Now this is another importance of this lithium aluminum hydride is that it also opens up this epoxide type of ring. It can also opens this epoxide ring, that is this type of epoxide ring also cleaved by this lithium aluminum hydride. Okay, you can easily convert to this epoxide to this alcohol via this ring opening process. Okay, now see, I am taking a few examples over here. That is this type of compound that is contain acid is also reduced by this lithium aluminum. We all know that this acid are reduced corresponding to this alcohol, so this is also here the same thing. And now this is your amide bond. We also seen over here in the chart, that is amide bond also reduced. So that is here these amides are reduced to this, and this is a very much important, that is this amides, that is C double bond of this type of groups are reduced via this lithium aluminum hydride by producing these two positions are two different types of hydrogen. Sorry, two different there is no produce of alcohol just because of this. If first of all this produce alcohol over here, so this alcohol is removed by this oxygen and nitrogen has a lone pair over that. So I am written over here like this way. This is your OH for first reduction, that is ketone is first reduced to this OH, and these bonds go over here. So this will leave from the system as a water, and here is your positive charge. So this positive charge is neutralized by this your hydride. Okay, so that is how the reaction proceeds. This hydride, so here is your two hydrides, so this one and this one. Okay, so that is how the reaction proceed. Now see, now this is also important, okay, for your exams. Now this is your I am taking two compound, the similar compounds over here. So see, there is an important selectivity of this reagent, that is lithium aluminum hydride. If we use in ether in presence of ether in 35 degree temperature, that is this is quite not good higher temperature, not lower temperature. It is a normal moderate temperature, or you can say it is room temperature, not room temperature, actually moderate temperature. So this, if we use lithium aluminum in this condition, it will reduce, it is just because of it will reduce this aldehyde and this double bonds, both of them. It is just because of lithium aluminum is much more reactive and more reactive, that is if it is much more reactive, so that's why this two bonds are cleaved, that is aldehyde and this aldehyde and this alkene, both functional groups are reduced. Okay, so if you want to reduce selectively only this aldehyde part, not this alkyl, not this alkene part, so we have to use if you can use this sodium borohydride. It is also a milder reagent, milder compared to this aluminum, so lithium aluminum hydride. Or you may use, you can follow this process, that is lithium aluminum hydride and temperature is lower. So if we lower the temperature of this process, that is in presence of lithium aluminum and temperature is lower, so its reactivity is quite lower from this normal lithium aluminum hydride. Okay, so that is why this reaction process only this aldehyde is reduced to alcohol, but this alkene binding part it remains intact. Okay, so these reactions also can achieved by this reagent, that is lithium aluminum hydride in presence of diethylamine. So in presence of diethylamine, it can also reduce only this aldehyde. Okay, so this is another process also, and it is done by room temperature. Okay, so this is your product. Now see, now the another part is that if you take a compound like this and use lithium aluminum hydride, we know this lithium aluminum hydride is quite stronger and much more there is stronger reagent, so it will reduce both of them, that is ketone and ester, both of them are reduced corresponding to the alcohol. This will primary and this is the secondary alcohol. So if we want to reduce selectively this ester, not this ketone, so how can you do that? So see, the process is nothing but, if you protect this ketone, we all know how this protection reactions takes place, that is if we use this N type of ethylene glycol, so this glycol in presence of acid, it will protect of this it is a protection but protective reagent of this ketone, so it will protect this ketone, and you get the further if you use this further in lithium aluminum hydride, you can get in presence of you can get this alcohol. Now see, here is a thing is used, that is water. That is water is used just because of to deprotect this acetal form. And this acetal form is deprotected to form the ketone. Okay, so this process can you achieve from this product can be achieved by this process. Okay, so this is how the reactions proceed. Now let's take another example. The other example is that in this type of cyclohexanone, that is a 4 position is substituted by a tertiary butyl group. If we use lithium aluminum hydride on its so how the reactions proceed. Okay, now how this type of products are formed. Now see, there is a different types of product are formed, that is equatorial alcohol and another is axial alcohol. Okay, so see, the percentage of the product is different, that is this is your 90% and this is your 10%. so this is actually your selectivity. Okay, so the hydride is attacked over here, so you can get this type of equatorial alcohol, and if the hydride is attacked from here, so you can get this type of alcohol. So this hydride takes place selectively from this side, and it will form generally the equatorial alcohol more. So this is your selectivity. But if you substituted this 1, 2 and 3 position, that is 2 by a 2 methyl group, that is you can substitute this 2 methyl group, then the different type of products is occur. That is, if you use lithium aluminum hydride, the axial product is from at much more, that is in 55%, and the equatorial hydroxyl product is from in comparatively less, that is 45%. Okay, so now see, now if you use this type of compound in presence of lithium boro, that is it is called this L-selectride. Okay, so this L-selectride is nothing but I am writing the structure over here. It is L-selectride, that is hydrogen. This is your methyl, this is your nitrogen, here is your boron, this is your methyl, this is your methyl, this is your methyl. Okay, so this is your overall L-selectride. So L-selectride you see over here, that is very much bulkier, so comparative to lithium aluminum hydride, so it is much more bulkier. So that is why this type of hydride donation is not possible, just because of this methyl group is there, so there is a 1,3 diaxial interaction takes place, so this type of hydride donation is not possible. So the hydride is selectively donated from this side, so that is why the 99% of the product of axial alcohol is formed, and the lower or less than 1% product is formed in equatorial amount. So this is a much more favorable process to form this type of axial alcohol. By using this reaction can be achieved by this L-selectride. Okay, so this is very much important for your exams. And then another example of this L-selectride. Okay, now see this borohydride, this secondary butyl, this is a secondary butyl group. So this secondary butyl group, if you use this lithium or in presence of potassiums also, so that is called, if you use this here, that is lithium, that is called lithium L-selectride. Okay, if you use this presence of potassium, so that is called K-selectride. Okay, so if we use this K-selectride on this type of compound, there is a formation of, there is a attack of this hydride in conjugate manner. So that is here, that is the regioselectivity of this reagent, that is the regioselectivity. Okay, so this is a regioselectivity. So this regioselectivity tells us that is this hydrogen is attacked from this carbon, and this will goes via this conjugate manner, and this form this OH over here, O minus over here, and you can get this enolate type of thing. And if we use H plus, and so these bonds go over here, and here is a negative charge, so this negative charge is takes up a proton, so it forms this one. If we use an electrophile on its if we use an electrophile on this system, then the negative charge takes some methyl from here, and this will leave from the system. So that is how the reactions proceed. So there is a methyl group, and this methyl group is first one. Okay, there is another important of this reagent, that is if we use L potassium selectrite, same thing, that is this potassium selectrite. If we use potassium selectrite, if the substitution of the methyl in this position, so there is a no conjugate manner addition. Okay, so this is just because of this just because of this bulkiness of this secondary butyl group. So that is why this hydride donation from here is not possible. So that is why it will selectively reduce this ketone directly. So that is how this product is achieved. Okay, so this is your potassium selectrite. Now next come to the next lithium based reagent, that is tributyl oxy aluminium hydride. Okay, tri-tertiary butyl. Okay, this is tri-tertiary butyl aluminium hydride. Now see, this is one more important reagent, that is if we want to reduce selectively this COCl, that is acyl group, if we want to reduce selectively in presence of this NC, that is cyanide, nitrile, or NO2, so nitro group, nitrile group, if we want to reduce in presence of them selectively, that is then this type of reagent is used. So if we use this one, you can easily achieve this aldehyde. So how this reaction proceeds, this aldehyde is over here, and this goes, and this will leave from the system, chloride minus. Okay, so this is how the reaction proceeds. Now if there is another example of this reagent, that is selectively it will, now see, this is a comparatively much less reactively reactive compared to lithium aluminum hydride, just because of this tertiary butyl group is reduces its reactivity compared to this lithium aluminum hydride. Okay, so this reagent is selectively reduced in presence of your esters, epoxide, halides, nitriles, nitro, any kind of reagent. So this will not this reagent not attack of this type of group, that is your CO2 any kind of esters, your nitro, your cyanide, or any epoxide. Okay, if we use this type of reagent in presence of aldehyde or ketone, so aldehyde or ketone is selectively reduced, but these groups are not affected by this reagent. Okay, so this is the importance of this reagent. Now the another important thing is that I have already said that it will also cleaves this type of bond, that is if there is any leaving group of there from this position, then is a cleavage of this bond, and there is a takes place of hydrogen. Okay, so you can get this one. So this is your example of this type of reagent, this type of reduction. Now see, if we use tosyl chloride in presence of pyridine, so there is two types of alcohol group is there, primary and secondary. We all know that is primary alcohol group is much more faster reactive compared to secondary alcohol. So this will generally faster form to this OTS bond, and this is your rest part. I'm not writing the all part. So if this is from OTS, and if we use this lithium aluminum hydride on this system, then this bond is cleaved, and if you get the final product, that is CH3, and all rest parts are there. Okay, so this is your final product. This is how the reactions the importance of this reaction. Okay, now the another important concept or another important thing is that if we use this type of epoxide ring, we all know that lithium aluminum hydride opens the epoxide type of ring, and it will reduce this it will reduce by this rings open by the ring opening process. Now if we use lithium aluminum hydride, then the ring opening takes place from this side. Or if we use this sodium cyanoporohydride, that in presence of this boron trifluoride etherate, then the ring opening takes place from this side. Why this type of ring opening takes place? It is just because of, if we use this Lewis acid, this is just a Lewis acid, boron trifluoride is just a Lewis acid, so it will take a proton from here Now this will try to open up to get back to neutrality. So that is why this bond is removed. This bond, if this bond is cleaved, then the positive charge over here, and this bond is cleaved, the positive charge over here. Which positive charge is much more stable? This positive charge is much more stable, just because of this. Here is a 3 degree carbocation, and here is your 2 degree carbocation. Okay, so that is why this bond is cleaved selectively, and the hydride donation, it takes place from here. This type of reagent we discuss on our next videos, when we discuss the lithium borohydride, sodium borohydride, or all those things. Okay, so and in lithium aluminum hydride, this hydride is selectively takes place from here. Hydride donation selectively takes place from here, and this bond is open up. So this is how the reactions proceed. Now the last and one more important example is that if we use this cyanide or this amide type of bond, CONMe2 type of bond, this will also reduce by this reagent, that is lithium aluminum hydride, in presence of O83, lithium aluminum hydride, O83, not lithium aluminum hydride. This is your derivative of lithium aluminum hydride, which we will discuss on this reagent. The same thing is used if we use this reagent on those two type of compound. We also get now see how the reactions takes place, that is this one to this one. Okay, how this nitrile is formed corresponding to his aldehyde. Now see, the mechanism is just nothing but that is this one, and this, there is your aluminium, and this is your hydride, and this O23 OET is here. Okay, that is what your product, that is what your reagent. And this now nitrogen has a lone pair of electron. This nitrogen lone pair of electron goes over this aluminium center, and it will coordinate with aluminium center like that, this by this way. And here is your aluminium, this is your hydride, here is your positive charge, and other parts are there. Okay, so this hydrogen will hydride is migrate to this carbon, and this is neutralized to this nitrogen center, and you get the final product, that is this one, and this is your hydrogen, and this here is your aluminium side part. Now this bond is hydrolyzed, and it will correspondingly formed its corresponding its aldehyde. Okay, that is how the mechanism, and this is how the reactions proceed. Okay, the corresponding aldehyde. Okay, so this is how your all of lithium based reduction reactions. Okay, so I think this video is useful for you, and if you find this video useful, share it with your friends. And that's it for this video. Thank you so much for watching.